Hello IB. Tonight we're looking at 12C and 12D. So this whole chapter of chapter 12 is all about vectors, what they are and how we can manipulate them. And then chapter 13 is all about how we apply them and use them in the world around us. So in 12C we want to formalize how we start putting vectors together. And in 12B we looked at doing it geometrically by drawing them up. But in reality, we don't want to be drawing vectors all our life, and depending on grid paper, etc. So in this section, we're looking at vectors that are in a plane. So we're talking about sort of a two-dimensional plane, not three-dimensional at this point. And we want to talk about the vector OP, which means a vector that takes us from O, in this case the origin, on our coordinate plane, up to point P, which we can see where that is. And the vector, let's just get it looking nice. So here's our vector that goes from O up to P. And we can see that we can get to, oh, it needs an arrow. So let's put an arrow. Okay, we've got an arrow now. So we can see we can get from O to P by going 2 in the X direction and 5 in the Y direction. So we've got an X component and a Y component of our vector. And the magnitude and direction can be described in terms of the distance in the X direction and the Y direction. It's like that transformation vector that we did with transformations of functions. The notation that we used before and we're using here again now is these two values, X and Y, written vertically in curved brackets. So OP can be written as moving 2 in the X direction and then 5 in the Y direction. So that's like that transformation vector we looked before. So this point is taking us, this vector takes us from this point up to that point. Another way we can write it, if we don't want to use this vertical notation, is in terms of what we call unit vectors. So a unit vector is a vector that's 1 unit long, so that's why it's called a unit vector. So it's 1 unit long, and it can be in any direction, well, in the main directions we want is on either the X direction or the Y direction. So we use the little symbol I, and it's a vector, to say that we're moving 1 unit in the X direction, and J is 1 unit in the Y direction. So this is saying, another way we could write OP is to say we want to go 2 units in the right, so we could go 2I, where I is our little unit vector, so there's a little squiggle on top to say it's a vector, plus 5J, which means we're doing 5 lots of these little unit vectors in the Y direction. So J is for the Y direction, and I is for the X direction. So again, that's a vector. All right. So it's just another way we can write these. It's a bit like having units, centimeters or meters. So I means moving 1 unit in the X direction, J is 1 unit in the Y direction. So these are called the component form, where we write it like those transformation vectors we looked at earlier, or unit vector form. So 2 different ways we can write them, and sometimes it's easier to write them in that form, sometimes it's easier to write them in this form. You need to be able to recognize both and operate in both ways. So here's an example from your textbook where we've got the vector OA, which takes us from O up to A, and the vector CB, which takes us from C to B. We want to write these in both component form and unit vector form. So if we do vector OA to start with, and we can have a look here and see if we want the component form, we want to see how far has it moved in the X component and how far in the Y. So we can see it's moved +3 in the X and +1, it's gone up 1 unit in the Y. There's our component form, and in the unit vector form it'll be 3I. We don't keep writing the wiggle above it all because it gets a bit tedious. And 1J, we don't need to put the 1 in front, we can just write it with the J. If we now look at our vector CB, so that's going 3 units in the x direction, 1 unit in the y direction. So our vector CB is, and as you probably already noticed, it's going to look exactly the same. And this is reinforcing the point that a vector tells us a direction and magnitude, it doesn't give us a location. So that same vector is in 2 different locations. It's taking whoever, whatever, from C to B or from O to A. So the same magnitude, same direction. This one down here we've got another vector, our vector A, that's in bold, telling us it's a vector. What are our components here? So here we go across this direction. So our components x and y obviously are at right angles. We're going 1, 2, 3, 4, 5, 6 units to the left, and then 1, 2, 3 units up in the y direction. So therefore, in the component form, we've got -6 in the x direction, 3 in the y direction. Or in unit vector form, we've got -6i plus 3j. So that's the way to write, so we can have positive or negatives in either case. Here's one we're going to leave with you and come to class and see how you go with this. We've got a regular hexagon. This is A and B. And what you need to do, we're going to start off with, if this is our vector A, and let's make it go that direction, and this is our vector B, can you go through and name all the other sides in terms of A and B? So name each of those sides in terms of A and B. We'll come to that in class. This one's a similar one. Again, we've got a regular hexagon, so it's the same problem. This is our B, this is our A, vectors going that direction. That side's going to be a repeat. What would this one be here? Can you name that diagonal of the hexagon? So we'll look at that one in class. In 12D, we want to come up and talk about the magnitude of the vector. How do we describe the magnitude? So if we want to know basically how long is that vector, that's the magnitude, then hopefully you've jumped straight to the fact that we've got Pythagoras, because we've got a right angle triangle with our 2 components, our x component and our y component. To get our magnitude, then we just simply want to use Pythagoras to get the square root of our x component, 2 squared, plus our y component. So that gives us 4 plus 9 is 13. So we get the square root of 13. Can that be negative? No. It's going to be, we're only going to consider the positive version of this, because it doesn't make sense to have a negative magnitude, because the magnitude of a vector is a scalar. All right, we're trying to find just a number, not a direction. Our component form for this vector was 2, 3. And our unit vector form would have been 2i plus 3j. So you've got to be able to think, if I'm given unit vector form, to be able to take your coefficients of the I and j to work out your magnitude. So the magnitude is using just this formula, which is based on your Pythagoras. So we can see if V1 and V2 are the component forms of our vector, or V1i plus V2j, then the magnitude is, that notation is the straight, like the absolute value sign. That tells us the magnitude is the square root of V1 squared plus V2 squared. So here's one set up in unit vector form. What would be the magnitude of this? Why don't you pause the video, have a go at it, and then check. So hopefully you've come up with this. We want the square root of, the coefficient here is 13 for our I component, so 13 squared, and then for the j component, the y component, it's minus 7. So you should take the minus with you, even though it's going to get squared out. But remember, the minus is important because it tells us it's going in the negative y direction, which means it's plus 13 to the right and minus 7 downwards. So our vector is looking in that direction. So minus 7 all squared gives us 218. That's the exact value, or three significant figures if we're going to round it to 14.8, and approximately equal signs. So unit vectors, quick talk about those. This is a vector with a magnitude of 1 and in a given direction. So for I, obviously, if that the unit vector for I is 1 in the x direction and nothing in the y direction, so the square root of 1 squared plus 0 squared obviously equals 1. And if we did it for j, the unit vector for j is nothing in the x direction, 1 in the y, so the magnitude of that is going to be the square root of 0 squared plus 1 squared equals 1. So they have a length of 1. What if we had a vector A and we knew it was 1/3 in the x direction, but we don't know what it is in the y direction? How do we find out what value that is, given it is a unit vector? So that means we've got some vector that is 1/3 in the x direction, and we don't know what it is in the y. That's our unknown. But we know if it's a unit vector, then that is 1 unit long. So we're going to use the same story. We're going to use the magnitude of this will equal the square root of 1/3 squared plus k squared. We know this is going to be 1 because it's a unit vector. So we've got the square root of 1/9 plus k squared. Squaring both sides, so we get 1 equals 1/9 plus k squared. That's k. Oops. So k squared is going to be 1 minus 1/9, which is 8/9. Oh, it's looking messy. Let's try it again. A bit more space here. All right, we'll try again. So 8/9, because it's 1 minus 1/9. So k is going to equal the square root of 8/9, which, my 9's not tidy, which is the same as 2√2/9. So if we take the square root, then remember, hopefully you've gone, hey, it could be plus or minus. Can it be plus or minus? Could if we had two possible answers. So in this case, if we had a positive, k is equal to 2√2/9, but could if we had a minus k? Yes, that is just as possible. So k could be also equal to minus 2√2/9 and still had a unit vector making up that triangle. So either answer is possible for k. Two possible answers there. These are unit vectors. Leave those, have a go with those, and we'll come and look at those in class on the next day. And there's a card game, so we'll have a look at that when we get to class as well. So thanks for listening. Make sure you make some good notes of those, and then we'll go through a couple of these final questions when we see you in class. Thanks for listening, and we'll catch you later. Bye for now.